Our next speaker is Tom Joseph. He's an advisory software engineer from IBM, and he'll be discussing the tooling infrastructure for PMCI protocols. He's also a maintainer for some of the IPMI repositories in OpenBMC and the PLDM repository.
Yeah. Thank you. I'm Tom. I work with IBM Systems in India, in Bangalore. Bangalore is called Silicon Valley in India, Silicon Valley of India. And I work on the PLDM protocol and the IPMI protocol. I co-maintain both. I work with the OpenBMC project for the last 3 years. Been active on the OpenBMC project. So my topic today is the tooling infrastructure for PMCA protocols. It's a continuation of the discussion that we had yesterday on the PMC, or the PLDM implementation on the OpenBMC. My colleague Deepak had covered that, but I'll just go through the fundamentals once, and then we'll get to the specific tooling aspect of this PMCA protocols. So the PMCA stands for the Platform Management Platform Management Component Intercommunications. So that's a name for a work group under the DMTF OS pre-OS work group. And what the work group does is to standardize the communication protocols, define the low-level data models, and the transport definitions between the management controller and the management devices. So for all those who have been working on IPMI, this is somewhere that the industry is heading. So it'll be something interesting for those who have been related to the IPMI world. So this platform management subsystem basically takes care of all the in-the-box communication within the platform. It takes care of the this kind of the platform, the monitoring services of like temperature probing, your voltage monitoring, your fan speed, and all those aspects, as well as this control functions of power on, power off, reset, and watchdog timers. So this shows all the protocols that are involved in the PMCA stack. So there are some components in the PMCA stack. We have the management controller, the management devices, the platform software, and the network controller. So these protocols all work together to enable communication between these components. So the BMC is a management controller. It basically aggregates all these management values. The management devices example would be a temperature sensor chip. Those could be we could have standard sensor devices where there are standardized low-level interfaces. There could be legacy sensor devices where it's not standardized. We could also have intelligent management devices which would speak protocols. And there'll be level of abstraction. The platform software takes care of, it runs on the host CPU, and it communicates with the management controller to exercise management functions. And the network controller takes care of the external network world connectivity for the management controller. So at the heart of this is the MCTP protocol, and that is the transport layer protocol that that allows the communication between all these components, between the management controller and the platform software, management controller to the management controller to the network controller, and to the management devices. So the MCTP protocol can carry different message types. The NVMe is one of them. The PLDM. The PLDM is the one that that we have started the tooling on, which we'll get to a little more detail. The NCTP control messages and the NCSI. The NCSI and RMI is one combination. Apart from that, all upper layer protocols work with the MCTP for the transport. One of the beauty of the MCTP protocol is like all the hardware specific physical layer specific bindings are defined in separate specifications. Okay, and okay, so what is the motivation to come up with this presentation and what we are trying to do? So we are working on the IBM servers, and we were using IPMI for the in-band communication between the host and the BMC. But we had quite a bit of limitations. We had heard about a lot of limitations that we have with IPMI, with the sensor numbers and few other things. But we wanted to try out the PLDM for that in-band communication with the platform software, and we wrote some code and we wanted to test that out. And we didn't know what to do about that. We didn't find any open source tooling that was available. So we reached out to the work group to see if any of the companies that are working on this protocol has a open source tooling for this. And we didn't get any open source tooling available. So we thought we'll start with that. And there was quite a bit of encouragement from the PMC work group to proceed with this tooling effort. So we wanted to kind of, as we develop the protocol, the PLDM protocol, we implement command by command. We want the tool development also to make progress. And also, if you would have used IPMI, you know that there are a number of tools available. You would have the IPMI tool, IPMI util, pre-IPMI. You would have heard about a lot of that. So one focus was to have kind of converged tool development for these PMC protocols, like get together all interested parties and work together on this. Another goal was to rapidly test the I/O adapters that support the PLDM protocol connected to the MC. Using these toolings, we could get the through information. We could get the temperature on those adapters. So we want to rapidly test out these I/O adapters. So we wanted to do that. So the state of development right now on the tooling front. So I think I have used IPMI tool for quite a few years. So the immediate name for the tool that came to my mind was PLDM tool. So we were implementing the PLDM specification. So we started off with the PLDM tool, and this PLDM tool acts as a requester, and it runs on the OpenBMC. Unlike IPMI tool that typically runs outside the BMC and targets it via network, the PLDM tool runs on the OpenBMC and runs as a PLDM requester. It is developed in modern C++, like other OpenBMC applications, and it leverages the CLI 11 parser, the command line, C++ 11 command line parser, which is like pretty simple with minimal syntax. You can get your things done. We reuse the libpldm library for the encoding and decoding of the commands. So this libpldm was a library that we developed for the protocol to take care of the encoding and the decoding. So that so we have reused that for the tooling as well. This library can be reused in any of these components that speaks the PLDM. Right now we are like our test team is writing functional test cases for this PLDM stack using this PLDM tool. So this is how this PLDM tool is right now fitting into the on the OpenBMC. The PLDM tool runs on the OpenBMC, acts as a requester, and so there's an MCTP daemon that's running on the OpenBMC. So that is kind of a like a multiplexer, and the responder, the PLDM daemon. What you see on the chart is the responder, the protocol implementation, where there are command handlers for each of the implemented commands. So the tool is also connected to the same daemon. It sends the PLDM request, and the daemon forwards it to the responder, and the PLDM tool gets a response back and shows the output. Pretty similar to what how the IPMI tool works. So this is another use case of PLM tool, where the PLM tool could target the I/O adapters. So the I/O adapters will be connected through some physical medium to the management controller. So the PLM tool can target the I/O adapters. It depends on the endpoint IDs that are assigned to the I/O adapters. The PLM tool will send the request to these I/O adapters, and the tool processes the response back. So these are the two kind of use cases that we are seeing for the PLM tool. We are right now the first use case we are our development team is using for testing out the command implementations. But this is something which we plan to use in the near future. So we could try out the I/O adapters. We could try out what like PDRs that are supported. What are the sensors that are there on the I/O adapters? Get the VPD information like that. Yeah, this is like the output of the PLM tool. It's very rudimentary right now. It's very basic. So we got a few commands implemented, like get PLM types and the get PLM version in the tool, and it supports some of these subcommands. Like the get PLM version takes a subcommand like what is the PLM type that you want to kind of prop the version for. So you could pass that. So I mean, this is something very basic that we started with. Like this can grow like based on the PLM protocol needs. Okay, let's some sample output for the PLM tool. This command basically gets the base version of the PLM for the base PLM type. So what the PLM tool takes care of is like it puts the MCTP header as the first 2 bytes. It puts the endpoint and the message type, which is PLM, followed by the PLM header, and then followed by the commands request data. Since this is a MCTP daemon is a what do you call a demux, it basically this what was sent by the PLM tool is looped back again to the PLM tool. So which the PLM tool gracefully discards it. But what comes as a response from the actual responder is processed, and right now it's just printed as a bits and bytes. We'll be getting to some of these enhancements later. But but we get the MCTP header, we get the PLM response and the data. And if you see that F1, F0, F0, 00 stands for the PLM version type, and that's like 1.0.0, like major, minor, and I think auxiliary from a version. Yep. Next, we have something called a raw option, quite similar to the IPMI tool. So when we are more focused on the protocol development to meet the deadline, so we couldn't put enough effort for the tooling effort. So we came up with something like a raw option, which will help. What do you call it? And whenever a new command is implemented, someone wants to script some of these requests, they can do that using the raw option. With the raw option, the only thing that's not needed is the MCTP header portion is needed, but you need to stuff in the PLM header piece, which is the first 3 bytes, and the request data portion. Yep, the response is identical to what we saw with the standard option. So this is something on the cards, the NVMe tool. So NVMe is like a register level interface for PCIe-based SSD. So these NVMe cards, SSDs will have this NVMe subsystem where there are management endpoints within the NVMe subsystem, which can be kind of queried from the NVMe tool. So there are two physical mediums are the SMBus and the PCIe, and so the NVMe tool should be able to speak to the subsystem using any of this physical medium. And it can be used for like querying the VPD information of this NVMe cards, do some monitoring, temperature monitoring, and all that should be possible. But this is something which we think that some of these folks who are actively working on the NVMe could participate in. Okay.
Previous page.
Oh yeah.
Is this following the NVMe MI protocol or to communicate with the NVMe subsystem?
Yeah.
Okay.
So NVMe tool is also just like a name given. It could be something that someone develops, comes up with something better. But yeah, so these are the future plans that we have for the for this tooling effort. One thing is to come out with human readable formats, so that the person who is running that doesn't need to go to the bits and bytes. It has a better output. Another suggestion was to come up with a JSON output. Like it will be like a custom JSON for each command. But what that can be used for is for the protocol validation suite, something similar to the Redfish, that we can write schemas for the requirements of like what protocols it should adhere to, and these JSON outputs could be used to see whether the protocol implementation matches. The JSON output also will probably help with these PDRs, which will print out a lot of information. Like it depends on the implementation, but it can throw a lot of output. So this JSON output probably will be useful to validate this the command responses. And something that something that we can do with that is also for those who are comfortable, like knowledgeable about the PLDM protocol. There's a concept of entity IDs, entity instance, and the containers. So it's like we can have what do you call PDRs for CPU cores. We can have those, and those will be part of those will be contained in the CPU. So those kind of hierarchy, we can have some kind of images generated out of this JSON, which shows how the what do you call how the system is organized. Those kind of output. And the next thing is to develop this into a family of PMCA tools. Right now we only have the PLDM tool, but probably come up with other tools based on the requirement. And we'll also work with the DMTF to upstream some of these PMCA tools, so that it's available for everyone to pick and use. And probably host it in where there's in the DMTF GitHub as a DMTF repository where some of these Redfish validators are there. Probably, if it works out well, upstream some of this code over there. So yeah, a few links for getting started on the PMCA tooling. So the PLDM tool implementation is out there in the GitHub. It is it's pretty simple right now, but please do take a look and try to review some of the code out there and try to contribute. So I was speaking with Ben from Facebook yesterday, and got to know that some of the code that he was writing for the PLDM firmware update, that can fit in this after in the PLDM tool and can be consumed by the community. So one of the objectives of this presentation was met when I spoke to him, that there's code out there which can be brought into this tooling effort. And I welcome everyone to take part in this PMCA work group. It is to get an update about all the recent specifications and everything that is happening for in-the-box communication. This is an excellent place to be. They meet quite frequently. There are calls that we can take part in. Yep, and the PMCA white paper will give more details on what I spoke now to get you a like an overall picture if you are quite new to this subject. Thank you.
I'm interested in the PMCI tool for the JSON format. Does it refer to the binary encoded JSON?
What I mentioned over there was not binary encoded JSON, but it was rather the output shown in a JSON format.
Okay.
So suppose we have like a PDR output, right? It has an entity ID, entity instance. Those coming out in a JSON format.
Mm-hmm. So do you have any plan for the BGL for PLM or RD redfish device management?
Yep, it depends on the development plans that we have, but that's something which we are interested in.
Okay.
Yeah.
So the tool communicates directly with the PLM daemon, and then
Yep.
the output would be JSON format, right?
Yeah. So that's not what we have done right now. Right now we what we put is out a raw format, but that's something which we are interested in doing.
So the use case for this is running from the host, or is it running from the remote administrator console?
Right now the PLM tool runs on the OpenBMC,
Mm-hmm.
but that can be run from from the host as well.
Okay.
Because it's a requester and it could run from anywhere. Right now it runs on the OpenBMC, but it should be possible to run it from the host.
Okay. So I mean, for out of band management, you have the redfish interface,
Yep.
right? So would it be kind of possible you make a redfish post command, for example, and it invokes the PLDM tool to get the data from the PLDM event receiver or whatever?
Okay.
Would that make sense? Or
Yeah, but I think there's a clear distinction, as I understand, that these PMCA protocols are all for in-the-box communication.
right?
Yeah, they don't cater to the
Right.
remote management, and the redfish caters to that.
Right. Yeah. What I was saying was redfish caters to the outside the box communication, right? In PMCI terminology.
Yep.
So if I mean the request can be in the redfish JSON format.
Okay.
But the PLDM, for example, the event log or event receiver implemented within the PLDM, you don't have a way to get the logs out other than the PLDM tool
Okay.
for outside the box communication.
Okay.
If there is some kind of communication link between the redfish front end and the PLDM tool backend.
Got it. Yeah. So for that, right now we at least on OpenBMC, the debug subject model acts as that common bridging factor. For example, we have this state sensors which are sent from the host to update the state of the host in the boot progress. So those messages come via the PLDM protocol, but those are reflected on the debug objects, but those debug objects are consumed by the redfish. So I hope I answered you, but the kind of bridging that we are trying to do is through the debug object model that we have on the OpenBMC.
Okay.
Hey, just one question about contribution. Do you expect us to, so if we want to contribute to this tool, should we send a PR directly on GitHub, or do you prefer like Gerrit or other?
The Gerrit, OpenBMC Gerrit.
Okay. So it's not through pull request on GitHub, right?
Yeah, it's like any other OpenBMC repository right now. So you can contribute to the OpenBMC Gerrit. Yeah, and the normal cycle it goes through.
Okay, thank you.
Yeah, but yeah, as we talked yesterday, right, the firmware upgrade piece that you have, right, is something which we can pull into this.
Yeah, definitely.
Yeah, so that someone can you can target any of the IO adapters, and you can do a firmware upgrade using PLDM tool.
Yeah, awesome. Cool. Thanks.
Yeah.
Any other questions? Thank you.
Yeah.